What's interesting is there's some parallel activity going on at the DOT level around the country, and obviously with ASCE, and so I'm really glad that you guys, Steve and Barb, are including us on what you're doing, because I think there's some excellent collaboration opportunity as we go forward here. So this presentation we gave actually just 2 days ago. So when Steve reached out, it's like, well, yeah, we've got the thing, but to condense it into 30 minutes is going to be. I'm gonna skip over a bunch of slides or just kind of get into some of the neat stuff here. But I've got Dan Colby on the line too. So I'm chair of the ASCE 75 standard. In case you don't know, that's our standard guideline for recording and exchanging utility infrastructure data. It's an as-built standard. And I'll kind of give an overview on that. I'll talk about the 38 update. That's the standard for mapping utility infrastructure already in the ground that we have to go back and find out. And that's the information that's being used for the 3D modeling stuff that WSB is doing, which is really, really good. Because I mean, what WSB has been able to do is kind of show the value of having good infrastructure data going into the design and how it can be leveraged, to avert a bunch of potential issues that would happen later on. So we're moving to proactive predictive engineering versus reactive construction practices. So and it's going to really mitigate the issues. Dan, so I'm also I was a chair of the Utility Risk Management Division, and I'm actually moving in, depending on how the election goes, but I think I'll be in a board of director position for the Utility Engineering Surveying Institute, Utility Risk Management Division, representing them. Dan is, you've met him before, you've heard his name probably in the past, but he's leading a committee that I think I saw on your agenda. It looks like there's a lot of opportunity to collaborate here. It's the Utility Data Management Security Committee for UESI. So there might be some things to exchange. So I guess with that, I'm going to jump ahead. Yeah, I think we'll just stick with that high level overview. I'm gonna have to skip this stuff, but we got some really cool stuff, and we could show you sometime if you want for some projects out in Oregon. But that'll be another time, I guess. And then we can talk about some. Dan will kind of touch a little bit, I think, on some strategic life cycle management strategies that are being implemented at Montana, Texas, and in Iowa right now. We're working with Iowa DOT on a project to basically outline, what they need to do in the DOT. So again, there's a lot of parallel efforts going on here. I'm going to do this. I'm going to just roll down here because we know about the problems. So we've got these two standards here that we'll cover. And again, this standard 38, and actually we just got a cover. This isn't how the cover is going to look. That was actually from the old cover. We got the new one drafted, was shot to us on Monday. So, but I didn't have time to put that in here. But this standard's for existing utilities, as I mentioned. It basically resolves the issue of poor records in the past. We didn't have standards for records, so some records are very good and some aren't, and it's just you don't know what you're going to get, and a lot of times there's a mix out there. So this kind of addresses that problem, and then this is to kind of get things straightened out. Now, interestingly, this standard ASCE 75 stemmed from the Canadian standard CSA 250, and we had 3 members from the Canadian standard committee on our committee to help us develop this standard. So and they've since taken our drafts, and I think there's going to be kind of a merging of the two, but we started with theirs. And one of the things they said was, hey, we wish we would have made it 3D, we wish we would have made it digital, and we wish we would have included the above ground infrastructure as well as the underground. So and that's what we did in ASCE 75 to make sure it addressed all that. Now we didn't want to define a schema, so we didn't want to get too far in the weeds. We just want to identify, okay, here are the data fields that we want to collect. And here's a list of names that you can use for those different data fields. So we could basically create a pick menu, and it's a framework for a schema that we provided. But it's an easy step to take this ASCE 75 standard and develop your own schema. And we didn't want to limit how that was done. So that's really up to the software vendors to take that. But Dan will kind of mention, he's on this OGC Open Geospatial Consortium committee also. It's called Modeling Underground Data Definition Integration. And that's taking these two standards and all your major vendors like Esri and Autodesk and MicroStation and Bentley, and, just across the board, they all comply with OGC and standards, and that's your WFS, the different standards that Dan can talk about. But anyway, they've already adopted these ASCE standards to be as input to their MUDI standard. The MUDI is the standard that'll allow it to be, the data will be just streamed around, shared seamlessly between vendors. Just to touch on 38 real quick again, it is an industry standard. I think it's been written into engineering, EGCDC, I think is what the acronym is, but they write the templates for contracts for design and construction and for major projects. And they've adopted this ASCE 38 as a basic practice, something you need to do when you do design work. And in Colorado, they actually took it and elevated it to a law effectively with their SB 18167 bill that was passed back in 2018. I gotta kind of zoom past this because the basic premise with the ASCE 38 is you've got these quality levels, and this is just a refresh on what's there. Really, we need a couple hours to talk here, so I'm going to have to stay fast. But what ASCE 38 does is it elevates the utility investigation process to a professional effort, like a property boundary survey or a geotech investigation. And you got to show you met the standard of care. Now, more on that, with the 38, because 38 historically was what we call a consensus standard. And now with the revision with 22, it's both a prescriptive standard, which means it basically is saying these are things you need to do, and then it's a performance standard, where it means you need to show you met the standard of care. And you better be able to stand up in a court of law, and your errors and omissions carrier better understand what you're doing if you're going to be sealing this stuff. So there's a lot of teeth behind it from a legal stance and a liability stance. So the idea was, there were people playing and saying they were doing SUE, but they weren't. They were still doing the pipe and cable and different services that are all elements or parts of the whole process, but when you put it all together and then you put somebody's professional responsibility on it, that's we needed to differentiate that. Well, let's see, I didn't want to stick on that. I wanted to show you just basically some 38. Here's an example in Colorado. Before this would have been an example of the typical records compilation, topo survey, and the information going to design. And this is after a 38 investigation. And again, there's a lot of things that often, we got a lot of examples of that. It's just a much more lengthy process to develop it. But again, it's the old measure twice, cut once thing. If we spend a lot of time getting the data and getting it right, getting it, in a standardized format. Using a lot of different tools. Using some more of these even these modern technologies. This is time domain EM. This is just showing some examples of the data. And again, I can't dwell on it here. Multi-channel radar systems that are coming out. This is state-of-the-art stuff here. We can drive road speeds down and get tremendous scans of the data, the subgrade. These are all just tools that we use to bring all this disparate data together, to stitch it together, and along with professional judgment, analytics, understanding how these infrastructure systems are designed and built, and the history of how areas evolved and where things are abandoned. Bringing all this information together to develop a 3D model that can, be used with some confidence to do your design work and do what WSB did on the project Bart mentioned. But this is just showing some of the multi-channel radar stuff. Again, these are just tools. It works well in some scenarios. It won't see everything, but it does see other things. And it sees stuff that often what we're finding with these tools is we're finding a lot of stuff that people didn't even know were out there.
Bill,
Yep.
Can I ask you a quick question? I'm seeing symbology here. Is there some standard for symbology?
Symbology?
Yeah. For instance, you've got solid lines and dashed lines and lines with dots in the middle of them. And
this one?
Yeah. I mean, it's kind of all over the place.
These are typically what we're seeing here are CAD standards. This would be Colorado CDOT CAD standards for their.
Hey, Bill, I can touch on that too.
Yeah.
You're exactly right. It's all over the place. But what it is that a lot of the DOTs have their own CAD standards, and they require it to be a certain way. So it changes from DOT or different agencies that we're working with. But yeah, I would tend to agree with you 100% that it's all over the place. But they know their symbology, and so for us to change it on them, it wouldn't go over too well. But yeah, it's a good.
And there is an effort as we move into 3D. I think you're going to see us departing from this 2D world and going into 3D here very soon, or it's happening right now. And there's an effort right now to. I think there's a research project funded right now for NCHRP, isn't it, Dan? That they're looking at how to depict these things in a standard way in 3D.
Yep. Yeah, it's going to be a lot more visually appealing. Let me put it that way.
Okay, thank you. I appreciate that. So that it kind of helps us with, we're working through the same issue right now on how to depict the difference between a locate and a line that has been submitted by utility. So, okay, thank you.
Yeah, and I think the way ASCE manages it's in the data behind the depiction. So if you can manage that in a lot of different ways. You can have it embedded so that when you hover over the line, then that information's available. That's how you assess how good it is and where it came from and all that. So, I mean, that's very important to understand when you're looking at it. But you don't want to clutter up your drawing either when you're doing design work. So text leaders aren't a good way.
I'm sorry, one last thing. What was the name of the entity that's working on trying to come up with some standards?
I'll have to look into that and find that out. I want to say it was an NCHRP research effort. I could ask, I'll check with Jim Ansbach. I talked to him earlier.
All right, thank you very much.
You bet. So let's, I mean, ASCE 38, by the way, I'm just going to go back here. It's just a touch on it. What we're doing is we're collecting so much different data now that we have to manage it in a more of a data-centric environment and stitch together to create something that's consumable for the design effort. And then also beyond that, for augmented reality, for machine guidance, for BIM, there's just a lot of different uses. But what we're doing is we're managing all the data behind it, like I was saying. So it's not just the CAD file, but it's more of a data-centric approach, and it's got to be staged in a way where it's a kind of treated like a work in progress, because we don't know. I mean, you're going to get more data as you go along, and things change. I mean, and you're going to have test hole results. You're going to have excavations that expose things. You're going to have old records that show up, and new installations that are put in. It's always changing, so you need to have it in an environment that you can manage it, and then produce CAD. But there's your 3D depictions here, and if on what we're doing right now is every point along here that was used to develop this is based on 2D information from one source and a third dimension from, it might be from electromagnetics or radar, or it might be an as-built, or it might be a test hole. And so we're managing those different data sets that they're merged together to make this what you're seeing here. This is what we use to do the design, to do the BIM, and a picture tells 1,000 words. This is where the 3D is so much more appealing than the 2D, because you can understand it. One of the things ASCE 3822 requires is not only the alignment of it and how you got it, but the space that this thing is occupying. So if you have a vault, if you have different sized pipes, you want to represent the full geometry in 3D, and have that as part of your data set. Let's see, I'm rushing through here. This is just showing some of the value. I think I've showed this, Barb and Steve have seen this before, but the value that you can achieve by having this kind of information going into the project. So basically, if the designers have this information, when you get to construction, it goes a lot faster, and it's a lot safer, and it doesn't supersede the damage prevention effort. That still has to happen, but the design has already been set up, to mitigate the risk, so that, and we know where we're going to be tight and where we have to be careful ahead of time. So anyway, but the big kicker behind these processes is what we call critical path analytics, and if we can reduce the critical path for the project, make that project be delivered faster and safer, that's where your pay dirt is. That pays for all the effort up front. And we've got, the example WSB has done is, really brought that out. So that was one of our examples from, 6-7 years ago, I guess. So when we get to ASCE 38, there's a lot of things that are the same. We still have the 4 quality levels. We still have engineering tasks that have to be done, value studies. That's been moved to the appendix. The geophysical methods are still present. But what's different? Well, like we said, it's got performance goals. There's a lot of commentary in there to help clarify the usage of the standard, because a lot of people are, taking records and calling it quality level D and say, hey, we met the standards. Like, well, no, that's and so there's been a lot of clarifications, misinterpretations. The goal of ASCE 30 is try to get everything to at least level B, and then A where you need it. And B is, rule of thumb is going to be about that kind of accurate. You can't say it's accurate because you're using remote sensing methods. It's not like survey where you can directly shoot it and get a survey shot, but you're using geophysical methods to develop an interpretation of what's there and where it is. And so there's a little bit of a lot of professional judgment that goes into the depiction. We just can't get the data to actually produce a statistical accuracy, like you can with survey, but you can have accuracy for the survey shot that's done on the paint, and that's called out in here. So, and then we include aerial, and so it's no longer a standard guideline for the collection and depiction of subsurface utility data, but it's a standard guideline for the investigation and documentation of existing utilities. That's the new title on it. So it includes both above ground and underground. And another thing about 38 is, like I mentioned, you want to get the geometry. So you want to, it's not just a manhole lid. You want to know the space that whole structure is occupying under the ground. And so you're going to want to go down and use LiDAR methods or other methods to document that and get that represented. they also talk about the advanced geophysical methods that I just showed you earlier, electronic depths, how to use that. 38 originally stayed away from depth data because it's like that was back 20 years ago. It was pretty guesswork using electronics. Now you get metadata where it looks at the circularity of that magnetic field, and it can tell you if you got a good circular field or if it's being distorted, and how well you can trust that information. So that metadata is being recorded now. So electronic depths are actually much better. Let's see. Again, it's a prescriptive standard and a performance standard. I think that's a big deal for the professional. That was to kind of help get the wannabes out of there that we're doing different things and not getting the idea that this really is, there's a lot of liability associated with it. And you want the statutes that regulate professional engineering to kick in for this product. This is an engineering product. And so that professional, you got to have a quality management program and a lot of documentation to back up that you did what you said you were going to do, because you could wind up in a court of law if something happens. No additional information is prudent. Do the critical path analytics is important, as I mentioned. Again, you want to try to come up with projects that are constructible before you even let the job. And a lot of times we can avoid things in design and come up with more sophisticated solutions rather than just relocate the utilities, which is probably the lowest tech solution, is to move that utility out of the way. It's like, well, you can't do that, especially in urban environments. Like, where are you going to put it? When are you going to put it? How much delay is it going to have? You can't shut that gas line down. Then how are they going to maintain their services? Blah, blah, blah. And if we can come up with, if we know where the stuff is, and we know what it is, we know a lot more information about it, we have in 3D, we can actually come up with designs that protect it in place quite often. And then we have better grip on the cost. So your change orders go down, and the risks are communicated. So they know where they have to focus their effort during the construction, and then expedite construction delivery. So, and the goal is to really look at the public, what's in the best interest of the public. That's a professional engineer's mantra, is, you put public welfare, public interest number one over your own project. And, that includes, disrupting businesses and traffic and the commuters and all the discomfort that goes with it. So it's avoid, accommodate, then relocate. That's the practice that goes behind the use of the ASCE 30 standard. So getting into the 75 standards, this is probably what you want to hear more of, and probably what I don't have time to talk about. We wanted to find the spatial, geometric, and feature attribute data. We just wanted to find, these are the data elements you need to record. How you do it, how you manage that, that's not, we're not defining that. We just want to say, these are the elements, okay? And then we have it, by having these defined, then now you can have it in a digital format. It's easy to exchange that information. So the idea is to get away on a design project from having to call the contract locating, the one call, having paint the ground, having somebody go out and follow up with a survey, and then transcribe it into CAD again. And they're bringing it in to do design work. There's a lot of pitfalls along that way. That's a good, for damage prevention, that's one thing. But for design, there's a less time-consuming, more direct process of doing that. And what we want to do is be able to just say, hey, just live reference your data repository into our design so we can do our design. And that's one of the things we're trying to facilitate here. And then they maintain the data set. We're just trying to set some standards here for how that's done. And again, we want to enhance a lot of different things. We'd love it to be able to, the idea of this is the data, once we collect the data for the design, to have it flow back so that when your damage prevention effort happens, those guys can put their Google glasses on, they can navigate with GPS to where that pipe and cable is supposed to be, and then they can, oh, okay, I got it. I got my EM and get the paint marks down and get things marked out with a lot more confidence and understanding. So really to up the game there. Yeah, we want digital data, 3D geometry, underground overhead, and focus on newly installed. So that's the best time to document this stuff, is when it's going to the ground. It doesn't get any better than that. You can do pretty well using the EM, the radar methods, but it takes time and it's a lot harder to go back, and you're still never quite sure. When you can see something and survey it, and with these LiDAR systems that are out there, you can just walk down a trench with a LiDAR on a stick, and just document things down to the I mean, it's not that hard. So, and then you mine that data out and submit it. So anyway, 9-year effort. We started in 2013. These are all the committees that were, or groups, organizations. I mentioned we had Canadians, we had OGC, we had the military, we had telecoms and contractors and horizontal drilling. Everybody came together and said, yeah, this will work. This is a good one. And this is just the table of contents, not a very thick standard. It's a pretty simple standard, I think. That's one of the beautiful things about it. At the end of the day, and I can't focus on much, but I'm just going to stick to some key things so you can walk away with. One of them is we wanted to use a common spatial datum. So we're using our national spatial referencing system. Everything you collect needs to be tied to that. I came from NOAA 30 years ago, and we were doing this for nautical charts, and most of your federal agencies are all tied, all the DoD activities, all tied to the National Spatial Referencing System. That's when you turn on your GPS system, your GNSS system, you're tied into that. So it's easy to achieve. And then instead of an accurate or quality level, we have an accuracy level. This parallels with the Canadian CSA 250 standard, and we have there's just a slight difference between their table and our table, but basically it's the same. And we have an accuracy level. So when a agency issues a permit to a utility, they say, hey, we want you to document that using accuracy level 3, for this area. We think that's good enough. And so and they might say 3 for horizontal and 4 for vertical or something, or maybe 5, whatever. It's very scalable standard, by the way. It's you can tighten it up to where you had a certificate of survey on that thing, or it's as loose as, like, use your phone and get the GPS coordinates, and we'll qualify it. Well, that data will be qualified so that going forward, it'll all be standardized in a friendly format that we can use, a consistent format that we can bring in a design, so we don't have all these different formats all over the place. But we'll also have the metadata about it, so we know how good that data is. So again, the standard was set up to be scalable. And you could if you had to deviate, say you're doing accuracy level 3, and then here we couldn't achieve it, so it's degraded to 0 at that point or something. It's all there. This is just general rule of thumb to achieve, like you're doing accuracy level 2 or 3. It's not that hard. Again, with the technologies out there, the LiDAR, the drilling tips on the HDD, that, by the way, the HDD is handled a little differently, where you can get accurate shots at the test pits and at the bore pits. But in between there, you're going to fall back to ASCE 38. And these two standards, ASCE 3875, are parallel standards. I should say parallel, sister standards. And 75 was written to accommodate the 38 data. You may not get all the data fields populated, but all the 38 information can flow in a 75 format and be shared accordingly. But for the directional drilling, for the remote sensing, if you're using inertial navigation or electromagnetic methods to get that board tip, that's considered quality level B data, and that would still be managed in the same way, but it'll be qualified. So as level B, it won't have an accuracy level, or if it does, it'll be indeterminate. So although that's changing too, because as the technology gets better, we can actually start doing some saying it's that accurate. Yeah, I think the other thing is the data gets reduced to the center of the geometric geometry or whatever you're managing. So if all your shots are on the top center of the pipe, what gets reduced and shared is that center line for the feature. And we do address data sensitivity. We fall back and use 49 CFR 1520, which outlines very well how to manage sensitive, secure information. Let's see, I think if there's a certification. I'm not going to touch on this. This is just some of the required, mandatory, minimum, I guess we call it, not mandatory, minimum, optional, and conditional attributes. And there are tables that go behind this, so it's real easy. And this is just a quick example of just doing a sewer pipe. One of the things that standard does recommend or require is when it's being administered is not only get the shots on the facility that's being installed, but anything crossing, go ahead and get shots on that too, submit that. We may not know what it is, but it doesn't get any better. Again, if you got something exposed that's crossing, get a shot on it and submit it, and then that information will be managed going forward. And again, we want to enable augmented reality. Not a big deal cost-wise. This standard has been implemented already in Montana and for new infrastructure for 2 years now, with all their permits for utilities going in the DOT right away. And the reception's been fine. I mean, it's been good. The utilities get it. They love it. We actually were able to implement a very good, friendly permitting system with it. Let's see, I think, your benefits achieved that greatly dwarf the cost. And one of the benefits, the utilities, they have to, whenever you do a pipeline job or a new install, they have to go through the same process as DOT does with the design. So they get to start sharing and having that information ahead of time. And that's what Montana's doing. So I think I'm done here now. I'm going to stop. This is probably a good transition here. I think, as I mentioned, the OGC muddy standard has adopted both the 38 and 75 as their input. So that's kind of an important thing to keep a finger on. So I don't know how I did the time.
Yeah, I was gonna ask that. How much time? If we don't have a whole lot of time, I can just kind of iterate on things versus.
Just one question. Could you just go back to that slide 55 with the return on investment? Just.
Yeah, you bet.
Just real quick. And then we've got some more time. Okay, I just want to. Okay.
So this is let me see here now. Yeah, this one is that's kind of an old report. So there've been like 5 historic reports done over the years to document. I think this Purdue study is the one that's documented or quoted the most for using ASCE 38. And this is a return on investment for using ASCE 38.
Oh, okay.
And what we did, there's an NCHRP report. Let's see, I think, right here. This was published last year. And we worked with Iowa State, Roy Sturgill, and extended from what the return on investment was from 38 investigations to what ASCE 75 data would bring about. And it's, this is just pretty conservative. I think it's actually more than that, but 10 times the return on investment for SUE. So we know that a positive return on investment for using ASCE 38. And if you start using 75 to document when stuff goes in the ground, it's roughly 10 times that. So if that makes sense, that was it's a no-brainer.
Yeah. Thank you.
You bet.
So Phil, I can go ahead and just run through.
Oh, do you want me to jump down to the slides down here?
Hey, Phil, while you're doing that, quick question for you. Could you talk to the issue of the availability of these documents? They're going to be issued in the end of July, is that correct?
Yeah, July 25th, just prior to the Pipelines Conference in Indianapolis, the standards will be published.
Okay, and the question that I would have is, to what extent are they available to the the public in general? Do you have to be a member of such
No.
and such?
Yeah, I think you get a little discount if you're a member of ASCE 30, but no, they're publicly, anybody can get their hands on it. So it's,
what's the price?
I think, that was being discussed. I heard numbers like $70 or something like that. But,
Okay, so it isn't, I've seen some instances where like the SAE standards, they're you're $600-800 before you have your hands on it. So
yeah, it might be
not a big
yeah.
deal. Okay.
I think they're talking about actually doing like a package deal. You get the 38 and the 75 together,
Okay.
and then as a package, and then you can you get I think a webinar with it too or something. Discusses.
Okay. All right. Thank you.
You bet. Dan, did you want me to touch on this?
Yeah, I mean, depending on time, I can kind of walk through with the group, kind of what we're doing with the DOTs and especially how those standards are being applied, so that we can kind of put the pieces of the puzzle together. Within the DOTs, we're dealing with their permitting application side, and Phil kind of touched on that. But we're also dealing with the DOT utility data repository. This is where we're capturing all the information. So as utilities apply for a permit to put their lines in the right of way, the DOT, and in some states like Colorado and others, but right now we're working with Montana and Texas also, and Iowa. Phil mentioned it's an opportune time to be able to start capturing some of this ASCE 75 data, because number one, they have the design plans that they're getting ready to submit to get approval for a permit to put their facilities in the right of way. And then secondly, when they do install those pipelines, that they can actually capture the ASCE 75 data and get that information directly into the utility repository. The stakeholder collaboration portal, what this is that it allows the ability for utility members and other stakeholders, could be 811, it could be, the one call, other state agencies, to be able to collaborate and share data, but where all the data sits in their system of record. So there's a lot of sensitivity around a lot of utility data, as we probably all know. And so a lot of times they don't want to replicate that data or even submit it to the DOT repository, but they will share it through a collaboration portal for a project purpose, to be able to minimize risk to their facilities and those kind of things. And so you can go ahead and flip through this really quickly. I'm not gonna, you can probably skip through this slide if you want to, Phil.
Yep.
So, and go ahead and just kind of click through to where everything kind of shows up on the screen. And so what you see here is that this is a structure. Oh, go back one more.
Yeah.
Right.
Yeah,
it's easy to do. So you'll see up top here these standards that are being implemented. And so you'll see the OGC muddy. You also see the ASCE 38 and 75. As Phil mentioned, those two standards complement one another. OGC muddy, that's the committee that I'm on. And I'm also on 75 as well. But the information, the point of it is so that we can pull this data in a standardized way to where we can generate a 3D digital twin and capture that information in the repository so that everybody can share things. So right now, we have a lot of information coming in from a lot of different people. So at the bottom, you'll see we have data coming in from utilities, a SUE process, engineering, 811, a traditional survey, construction, permitting. There's a lot of data. These are just examples of information or mechanisms of resources that are bringing data in. And so you'll see on the left there, there's examples of data inputs that are coming in. And Phil mentioned some of them, like there's GPR, geophysical data, but there's 811 ticket and locate data, there's permit data, but there's as-built data. The list goes on. And this is probably not even, this is a sampling of the type of data that comes in. So we're dealing with a lot of information, a lot of data coming in, a lot of different formats, a lot of different, in some cases projections, and they're not standardized in one particular way. And what this repository does is it standardizes. So on the outputs, you'll see that the business rules, the standardized GIS formats, the attribute rules, all that is completed in this one repository. And now you can go ahead and flip, Phil, to the next click. And so those outputs come in and they become the inputs for this collaboration portal that I was talking about. And so we still have all these standards that are being applied, and there can be other standards here too. So these are just examples. But where we really get into it here is with the OGC, all the major applications from Autodesk, Bentley, Esri, from the GIS, they all can communicate today. And they couldn't do that 4 or 5 years ago in some cases. And in some cases, some of these newer standards like MUDI are just out. And so what it allows people to do now is be able to do a bi-directional sync with this. So stakeholders like utilities can share their sensitive data securely. And so what the MUDI initiative has really done is it's taking the two worlds between CAD and GIS that have been separate worlds, and it's merged them together so that you can create a standard to where all these applications that are OGC compliant, which all the major ones are, and they can read and write those standards. So now you can share directly from GIS to CAD without doing a major data conversion, right? And so it's extremely important because there's been a lot of loss of data between those conversions as well. And so by having it in a standard and then being able to adopt the ASCE 75 and those standards, that it allows for this web services integration to happen and allows the sharing of this information between different entities. So I know I went through that really quickly. So it's like we're drinking water through a fire hose, but this is an example of a collaboration portal. And so this data can be shared. So let's say if a utility A wants to only share it with the DOT and no one else, there might be other stakeholders of that project, but their permissions and roles and settings can be restricted. But there are scenarios where they do want to share data directly with another utility because they want to be able to make sure that they can work together to make sure that they can minimize the risk of maybe their fiber optic line being hit or something like that. And so, but they can share it but they're the system of record. So one good example I like to use when I'm trying to explain this is that we also have weather that can stream in as well. So weather comes from NOAA, and we're not replicating that data, but we're streaming it in live. So it's dynamic information. We don't manage that data. It's managed at a system of record at another system, right? And so utilities have their own GIS systems. They have their own data. They're collecting a lot of really good information, and especially during the as-built construction time, but it's data that we don't normally see outside the utility. But now working with those utilities in Iowa, there's a huge effort going on where we have all of the utilities within the entire state that are part of this stakeholder initiative to be able to start collaborating and sharing their data. And so we're addressing a lot of the security issues and those kind of things. But the really nice thing about it is that so if you click a couple more times, Phil, and then I'm done actually. Like he was showing you that GPR data, like information from the SUE process can then be also shared with the utility members, and they wouldn't normally have that information because the SUE study was done for the DOT, right? And so being able to stream that information in and collaborate and bring all the data sets together, but have them sitting in their own respective databases is extremely powerful now. And so anyway, I think with that, I think I'm good. And unless you guys had any questions on it.
I did have one question. You've glazed over at a couple of spots. How does LiDAR fit into all that?
Oh,
Yeah. Bill probably can.
well, yeah. So we're LiDAR, is just another survey tool, basically. And so, with the aerial LiDAR, with the downhole LiDAR, mobile LiDAR, I mean, you're basically getting everything's geo-referenced. You get thousands of very accurate points out there, these clouds of data. And the only trick is you have to be able to manage that rather dense data set, large. I mean, you talk about terabytes of information, and you need to mine it and reduce it to something that's consumable for data management.
Yeah, another good example is that in this collaboration effort, a lot of times that LiDAR data will capture information that maybe even the utility owner was unaware of, right? And so having that also data within this process, within the collaboration side, has been extremely useful in working with the utilities too, to understand that there's other data and then they can use to rectify their own records too. So, but that's just one tool in the toolbox, right? But yeah.
where we're plugging it in is for that criteria in ASCE 38, where we need to understand the spatial occupation of those structures and vaults under the ground. It's a wonderful tool for logging it. And the other thing is like, so we have a limited time where we get into the street, we can drop this thing down, scan the whole thing, get all the pipes and all the dimensions and all the inverts, and everything's there. We don't have to go back to it now. We could, so it really helps us from a data collection process, And then the above ground stuff is wonderful too, because you can get where it all attaches. And so LiDAR is a huge tool that will become more mainstream with all projects. I mean, it's.
So Phil, I have a question for you, if I could.
Yeah.
Can you talk to the issue of depth? We've more or less in our thinking about data flow had dismissed depth as being an issue related to the potential for earth movement on top to functionally change depth. So how did you guys tackle that?
Depth for SUE investigations or depth for as-built?
Well, it seemed to me that across the spectrum, you were reporting depth of your, based to the center line of the item. And so as a NOAA guy, I'm guessing you're going to tell me AGL, or I should say above mean sea level is really what I should say.
I see. Yeah, exactly. So for 75, the depth would be your orthometric height. It basically perpendicular to the gravity field at that point. So it's instead of, so your national, we're using NAVD 88, right now to tie it to that. That makes sense. Are you a surveyor? Do you have is that, who am I talking, Steve? Is that you? Or?
Yeah, I apologize. No, I was just trying to get my brain around the fact that from the locator perspective, and Travis is on the hook here and he can chime in, the issue that as a locator locates something, he's, as I understand it, is making a measurement relative to the surface level of the depth of the item. And so I'm just trying to get my brain around
the ground surface. The depth below ground. So we're trying to take that one step further. So, like when we collect data for 38 investigations, we're going to survey that paint mark on the ground. And then we have actually several different tools. The depth will be measured. We're using RTK GNSS methods, for all our navigation work, for, whether we're on a radar or time domain EM or pipe and cable locator. So we know exactly the position on the ground. We've got, I should say, within the accuracy, XYZ, we've got the elevation, the orthometric height, and the horizontal position. And then the depth is relative to that point. So it's tied.
If something changes on the surface, I think that's what you're getting at, right? There may be an earthquake or earth movement. And
we've got the elevation tied down to it.
But it's going to be based upon that depth, right, Phil? It's based upon the current state of when the data was captured. So if there was a earth movement for some reason, then it would no longer be correct. You'd have to go back.
Well, yeah, but it should be. And that's part of the thing we're tying into the National Spatial Referencing System is they actually do, when I was at NOAA, we track continental drift. So, you could get 20 feet of horizontal movement in California, near the San Andreas Fault. That's not uncommon. But if you're tied to the National Spatial Referencing System, they're actually keeping track of that continental, even the earth, the crust is still rebounding from the glaciers, so it's actually, we're still coming up, especially you folks in Minnesota here. may not feel
So,
it.
so I had one question, the financial model with the DOTs, who's paying for all of this capability? How does that
Okay,
get funded
that's a
and
great-
supported?
That's a great question, Barb. With the way it's working, say in Montana, is they're levying a small permit fee with every utility that goes into the right of way, and that it's not really a permit fee, but it's like a data management fee, that goes, and it's like, I want to say it's $50 to $100 or something like it. So when they apply for the permit, they pay that fee, and that money gets pooled together to basically pay for the management of the data repository that the DOT's handling. So they're using an off-the-shelf data repository, a commercial off-the-shelf repository. It's maintained, and I mean, basically, I think the costs are pretty well covered. I think they pay a nominal fee for licensing and things like that, but or they could pay for a permanent license. It is variable there, but the best business model for a DOT or any city agency or whatever that's managing a repository is to it's like a user fee. I mean, if you use the right of way, pay the small fee, then we'll be able to track that data going forward. So I don't know how Texas is doing it. Dan, do you know? I want to say
Yeah, I think it's similar.
I think it's similar. Yeah,
It's built into their permitting fees.
Okay, so the DOTs put in the system, they own the system, and
Yep.
then they charge a nominal fee on every permit. Okay,
You got it.
Yeah.
Yeah.
thank you.
But one of the things we're trying to do, Barb, is to not necessarily say. I mean, we want to create an environment where that data can be shared back and forth in a standardized format. So, like Dan was saying, the optimal way, I think, would be like a gas company. They manage their data, they keep it secure, they keep it current, and they just window their data into whatever else is where it's being needed. So even for damage prevention, they could window their data out. That's coming. I mean,
The minute you try to replicate data, it becomes out of date, right? So you make a copy and then they shoot it out. And that data is really dynamic, yeah. And it's and they're maintaining it, and you can't. It's really hard for a DOT or anybody, a third party entity, to maintain another person's data set, right? So, but yeah, it's that's why I use that weather as an example. We certainly want to try to manage that data. But yeah.
I don't know if we probably need to tune in a little more with what you guys are doing.
Yeah. No, this has been very insightful. We thank both of you for coming by and doing this. And just maybe kind of follow up on Dan's comment. That's exactly why we've steered away from any sort of a model that is about collecting data and bringing it in. And we basically are following the same approach that you've discussed here to facilitate through WMS and WFS the roll up of data to facilitate delivering.
It wasn't drinking water through a fire hose then, right?
Yeah, we're tuned in, but again, I'll let Barb chime in also, and thank you very much for both coming by.
Well,
Thank you so much. Yeah, excellent. Bye-bye.